presentation, and I kind of left it blank because, not intentionally, but when I was asked to potentially give a presentation today, one of the topics was trash talk. It's always easy to get people excited about talking about trash and what we should do with our waste, although Barry does a very good job of getting people excited about our transportation system. But what I want to talk to you about today is to give you a bit of an overview of some of the technologies that exist in terms of waste management technologies and waste to energy, which is something you hear a lot of. The title of my talk that you see in the presentation is dealing with waste or resource. Okay? There's a big shift, I think, going on now in terms of how we view waste and what's in what we consider that waste stream. And people no longer want to call it waste anymore. You're hearing the term residuals. Okay? Agricultural field, it's agricultural residuals. It's not waste. In the wood industry, it's forestry residuals, and I even hear people say now it's municipal solid residuals instead of municipal solid waste. But there is a lot of value in those streams, and that's part of what I'm going to focus on today. Then I'm going to take a little step back and say that we need to take a bigger picture approach to some of these issues. Okay? The province in 1980, exactly what year came out with the Waste Diversion Act, and said, okay, we must try and divert as much waste as possible. Well, that is good as a philosophy, etc., but you do need to take a look at the big picture and say, when is it important to recycle, reuse, and reduce, and what are we actually doing? And I'm going to kind of talk about the green bin program. How many people here use your green bin? I thought I'd get a lot of hands. I do as well. I think it's very, we've got it in place, we should use it, but I'm going to show you a bit of a look at that program to say, well, it really doesn't make any economic sense or energy efficient use sense or greenhouse gas emissions sense. Okay? It depends on how you look at that picture, and I'll try and explain that as I can today. And then I'll tie up with some of the questions that you'll be talking about as we go forward. Plasco. We have somebody here who can correct me if I'm wrong, but I'm going to go through a number of technologies. Everybody's heard of Plasco? Okay. So this is their facility out at Trail Road where all of our municipal solid waste goes in terms of the Trail Road landfill. And what Plasco is this a technology based on plasma arc. It's existed for a long period of time. People have tried this before. What it is, it's a high energy arc that goes and breaks down everything into its elemental components as best as possible. So what Plasco and other companies are trying to do is to take that technology and try and make it more energy efficient and economic to do. Okay, so this is a schematic that they have for their facility where they bring their municipal solid waste in, they shred the waste, okay, and it drops into this conveyor belt, and then it's heated, so any of the volatile components and the moisture and the things that will go into the air phase move into the air phase, and then that moves up through here, and then it's hit by this plasma torch. Okay, you're looking at a couple of 1,000 degrees Celsius. Okay. And then what it does is it produces a syngas, and then they can use that syngas to produce energy. What doesn't volatilize or move up this as a gas falls here and comes into another container where again it's hit with a plasma torch, okay, breaking things down into a gas, hydrogen and CO2 and others that come up here to your syngas. And then what falls out the bottom is what should be an inert material, okay, that they want to then use potentially as a road-based material or as a construction material, etc. And there are some other byproducts that do come out of this. Okay, but what you see is this idea of there being syngas, potable water, salt, and this has changed over time. There are some hazardous materials that do come out of this that need to go to a hazardous waste landfill. So there isn't this idea that there's zero waste, okay? Does anybody remember Ruth Greer? Yeah, the Minister of the Environment for the NDP said there's zero waste. It's a goal to strive for zero waste, but you cannot achieve zero waste. Okay? Every process does have something that goes along with it. So you're dealing here with a process that gets things up over 2,000 degrees C. Okay? Another technology is gasification. Actually, I shouldn't say pyrolysis and gasification are similar, but I should have changed this to actually be gasification. Enerchem, again, is a Canadian company. They're setting up a facility in Edmonton. So what they do is they take the shredded waste, and it goes at a temperature of about 800 to 900 degrees C. And it produces a syngas as well. And they take that syngas and they convert it into methanol and then into ethanol, okay, that they're going to then blend with gasoline. They've set up a pilot project not a pilot project, a full-scale project in Edmonton. If the city of Ottawa could ever get people out to the Edmonton Waste Management Center, it's incredible what they're doing there. And education is a big thing. Every grade 4 student in all of Edmonton, I was just there a couple of weeks ago, every grade 4 student tours that facility. And on each facility, when it's the materials recycling, everything goes into 2 bags in Edmonton, a black bag and a blue bag. And the blue bag goes into the materials recycling facility. There's a gallery that you can walk around, and each stage is explained. It's incredible. But when you talk about educating the youth and the kids, they do an excellent job there. Okay? But this is what they're building in Edmonton, and again, amongst many processes that occur at their waste management facility, waste here is shredded, and it produces a refuse-derived fuel, is what they call it, but it's just a shredded waste that ends up going into a gasification plant to produce, again, power in the end. Incinerators. Everybody likes that term, right? Okay. Incinerators is what we used to have. Okay, it's like lamp dumps is what we used to have. Incinerators are now called energy from waste facilities. The thing there is now we're dealing at temperatures. We've gone from 2,000 for plasma arc down to about 800 for gasification. We're down to about 500 degrees C for our incinerators. Okay. There, the big cost is, yes, we can produce a lot of heat and drive turbines, etc., to produce energy, but we have a lot of things that don't completely combust in that combustion process. So we have an extensive treatment of the gaseous phase, or the gas stream, before we can emit that. Now, in the past, with old, inefficient incinerators, that's an old image, okay? Then yes, you had lots of particulates and lots of things getting into the air. Okay? Today, the regulations are much different there. Okay? This is now big in Europe and other parts of the world. This is in Burnaby. They have an energy from waste facility there. Okay? In Ontario, we are looking at this. We have the region of Durham is trying to go through a rather lengthy public and provincial process in terms of getting certified a energy from waste facility. Okay? So you've gone from 2,000 down to 800, down to 550. Then you can go to looking at anaerobic digestion. Okay, what is that? Well, that's where we allow natural microorganisms that are in the waste. Okay, they eat away at the organic component and produce a gas. And that gas is 50 to 55% methane and 40% CO2 and a couple percent of other components. And then we can take that gas and convert that gas into power. So at the Trail Road landfill, for example, here in Ottawa, at Waste Management's Carp Road facility, at a lot of different facilities, they now collect the landfill gas and then they convert it into power. Okay? The best use of power, well, this is just one of the gas collection wells, but the best use of power is to use it directly. And this is in Saint-Sophie, Quebec, where I have a little research site, where these are the blowers that draw the landfill gas out of the site. It's put into a pipeline 13 kilometers away to a pulp and paper facility, the Cascade Pulp and Paper, where it's used directly as a heat source. That's the most efficient way to use that as a good use of energy, okay? Because you don't have the losses. This is their gas collection facility in Saint-Sophie. This is in Waste Management at the Carp Road landfill. They have 5 22-cylinder Cat engines that combust the landfill gas to produce about 6 megawatts of power. Okay? And then they put it on the grid. What kind of drives this is, again, legislation in Ontario with the FIT program. Okay, feed-in tariff, they get an increase in the energy that the price that they get for the power that they generate, even though these engines are only 33% efficient. Okay? A lot of the energy is lost to heat. Okay? So it's not the best way, but what drives it, and I'm going to mention this throughout, there's a lot of policy issues in the waste management field that drive things in certain directions. Okay? And so those are 4 of the different technologies that exist. This is again the outside of the facility. These are the stacks from those 5 CAD engines that exist. Okay? So we have different options. Okay? And we have different opportunities. We have different companies jumping into the game with the Plasco, with the Enerchem, etc. And so it is good to look at these different options. What I want to talk about today is a little bit dealing with having a bigger picture and looking at things from a life cycle assessment approach. Okay? I'm going to talk to you about the Waste Diversion Act. Okay? Ontario put forward the Waste Diversion Act to divert 60% of waste by 2008. Are we diverting 60% of our waste in Ottawa? In our residential? No. That's in our residential. Are we diverting more or less in the industrial, commercial, and institutional sectors, or the ICI sector?
Much less.
Much less. Where does the ICI waste go?
U.S.
Why?
Cheaper.
Yeah, because they can dispose of it there in a landfill. Okay? And it's probably the guidelines in the U.S. are less stringent than they are in Ontario. Ontario passed guidelines for the construction of a landfill, and I teach a course in landfill design. Okay, that landfill design is very protective of the environment. Okay, it's not a dump. When people jump out and say we're going to site a new landfill and call it a dump, I take offense. I spent a lot of time teaching engineers about how to design things so that it's protective of the environment. Okay? We're just providing different choices for each of us to pick in terms of landfill or waste management system. But right now, we might not like to have any kind of thing because of NIMBY not in my backyard, but we're all quite comfortable, okay, with all of our ICI waste, which is waste that we're responsible for. Okay, it's the big companies that we buy their stuff, etc. It's all us. Put it on a truck, ship it to New York, where it goes into a landfill. Right? So there's a lot of things that we need to look at.
Or garbage.
So I'm going to talk to you about and use as an example the Ottawa Organics program, just to generate some discussion and shed some light on how we might want to look at these things. So this is what we have in Ottawa. We have our blue bin and our black bin for our plastic, steel, aluminum, etc., and then our papers that go into our black box. We have leaf and yard waste, okay, and then we introduced our green bin program. The Waste Diversion Act is meant to save on our expensive landfill, right? To not use up landfill space. What fraction of the waste do you think we currently send to landfill as organics?
20%.
Actually, it's quite a bit. It's actually upwards of 25% or more. Don't quote me on that number. I'll get you an exact number if you'd like it.
As measured by weight or volume.
Well, this is the important part. Okay? When we divert something, we're trying to save landfill space. Okay? But that organic waste that's in the garbage doesn't take up a lot of space, because it's that component that actually is within the garbage that allows us to provides the lubrication, etc., that allows us to compact that garbage, okay, and it fills in the small pieces. Okay, it's some of these other items that are bulky items or what have you that take up a lot of the space. So if we divert 30% of the by weight the organics, are we saving 30% of the landfill space? No. And what do we do at Trail Road? Does anybody know what we do at Trail Road with the landfill gas?
Landfill gas.
Yeah. Because the organics that we put into the landfill end up breaking down and biodegrading and producing methane and CO2, which we then have to collect by law. Okay? And up until, for many, many years, we've just gone and put it through a flare to burn it. The reason we have to burn it is because methane has a global warming potential 25 times that of CO2. So if we burn it, we convert it from methane to CO2. Okay, but at all landfills, we have to collect the landfill gas and then either burn it or in a flare or use it for energy. Okay? So what you're doing is taking away the organics that actually help get that anaerobic digestion process going to help degrade those organics and other degradables within the landfill. So in Ottawa, we have different strategies that we looked at for a model. This is some work of a student of mine that dealt with using a model in the US that I'll talk about in a minute. But we talked about different landfill strategies. We have our black box and our blue box. We have leaf and yard waste. We have our residual solid waste. Okay. At one point, we used to just flare it, i.e. burn it, and now we look at energy recovery. What I'm going to focus on today is we introduce the green bin and some of the issues there. And then these two strategies are what we call a bioreactor, whereas when we design the landfill initially, okay, we place horizontal pipes within that waste so that we can actively collect the landfill gas as it's being produced. Okay? At Trail Road and at Carp Road, okay, those were designed as, well, the initial phases weren't designed as landfills. The initial phases probably, especially Carp Road, could be considered a dump. There was no liners. Under stage 1 and 2 of the Trail Road landfill, there was no liners. Now there's a requirement for a double composite liner, and I won't get into all the details. But we still are going in afterwards and putting these vertical wells into the landfill to try and collect the gas. The best way to do it is design your landfill from the outset to collect that landfill gas. Okay, so these are what we call the bioreactor strategy. The difference here is we collect probably 70% of the landfill gas. The difference here is we're collecting now 90 to 95% of the landfill. So this is the model. It's a model that's been developed over the past decade by the US EPA. It hasn't been released yet. It should be released later this year. They're building a user interface so that anybody can go onto the web and use this model or download the model. It's a very detailed model. I'm just going to give you a very brief introduction. It deals with everything from the curb. Okay, so we have a truck that goes to the curb and picks up your waste. And so we can take that waste and we can recycle it. We can look at our blue box and black box. We can look at landfilling it, and then once we landfill it, we produced greenhouse gases. We have to collect those and flare them, or we can use them and produce energy. And now that's offset on our energy mix. Okay, so in Ottawa, you plug into this model what Ottawa's energy mix is in terms of about 35% natural gas, what fraction of coal, a large chunk of nuclear, and some hydroelectric. Or you can put it into a energy from waste incineration type project, okay, to produce energy. Or you can take a fraction and compost it. You can compost it as we do here in Ottawa now through Orbital World, which is an aerobic process where we add oxygen and it just takes things and produces, the aerobic process produces CO2, okay, and that CO2 is released, but that's a natural process, so that's not considered greenhouse gases in terms of biogenic greenhouse gases or natural greenhouse gases. Or you could take those components and degrade them anaerobically without the oxygen to produce the methane, and you could generate power with that. And then anything else that you recycle, if you recycle a tin can, okay, it looks at the costs to collect that tin can, okay, and to transport that tin can to the factory or to the mill where they're going to recycle that tin can and reintroduce that tin can into the manufacturing. And it offsets all of those costs against going with the virgin product in terms of exploring for bauxite, finding the bauxite, getting the aluminum, transporting the aluminum to the manufacturing. Okay? And so it compares all the energy, greenhouse gas emissions, air quality. It looks at NOx, SOx, particulates. This model has everything built into it of the recycling and compares that to using virgin products. Okay? And then it tries to look at, you put into this the system, and my student built the system for the city of Ottawa where we include in there the costs for wages for truck garbage collectors, the labor costs at the leaf and yard waste facility, and where our recyclables go and what the city gets for its recyclables, where some of, all of these parameters that are fixed for the City of Ottawa, we've included them in this model and tried to look at this whole question. Okay, so let's look at costs. We're not going to be too surprised at costs, and I'm going to try and do this as quickly as I can, but this is the total cost. This is the cost of collecting your waste, okay? We don't have transfer stations. I won't explain those now. This is the cost of separating the waste at the materials recycling facility. This is the cost of what we have for treatment. This is the disposal cost at the landfill, for example. We don't have this transportation between centers. And then we have remanufacturing costs. So this is the money that we get back from our recyclables. Okay? So it's very small, but you can see that the transportation and collection is the biggest cost, okay, to our waste management. We did this without knowing any numbers from the City of Ottawa. This is in US dollars, but it's $35 million a year, and that's about exactly what the City of Ottawa does pay for its overall waste management scheme. This is with our current, or this is with flaring. This is with the current system when we used to flare it. This is with energy recovery. There's very little difference in cost. The yellow is the organics program. Because what we did, okay, there should be no surprise there, right? Recently now, we've talked about reducing the number of trucks that are going to collect our residual waste. Okay? Everybody was up in arms that we're going to have less trucks. But everybody was up in arms too when we introduced the green bin program and said there was going to be additional costs. They didn't want that additional cost. Now everybody's fine with keeping some additional costs if they can have garbage collected every week. I'm probably talking to the converted here, but I use my green bin, and if you use your green bin, there's not a whole lot left. If you do a good job of recycling, etc., that's in your residual waste. Okay? Once every other week is going to be more than enough for myself for one garbage can. But we haven't done that yet, so we've added a lot of transportation costs because we put an extra truck on there. Okay? There's not much difference in, we're here as a treatment, this is Orgo World. Okay? Because we are paying how much per ton of organic waste? $94 a ton. And we promised them 80,000 tons per year. This year we got to about 50-some-odd thousand tons. So really what we did in reality is we ended up, to use your math, we ended up paying about $130 a ton. Right? And before, leaf and yard waste used to cost us how much at Trail Road to put in windrows and turn? About $15 to $20 a ton. So we were paying a lot of money, okay, for that organics diversion program, okay, to save our landfill space, where in reality at that landfill we have to collect the landfill gas anyway, okay, to make sure that we don't have emissions for greenhouse gases, and we can collect that landfill gas to produce power. Okay? So, depending on how you look at things, well, let's look at things from the point of a greenhouse gas emissions. Okay, and one thing I want to point out here is, remember earlier I showed you the little cost that we get for recyclables, very little cost, the market's not really there. But if you use this life cycle approach, there's significant reduction in greenhouse gases if you use those recycled materials. Okay? Getting those virgin products from, I'll go back to my aluminum can, getting those virgin products, getting that aluminum, all of that emits lots of greenhouse gases. And so there's huge savings in terms of reduction in greenhouse gases, but we don't get economic value for it. There's something wrong with that whole picture. But if I remove this system and say, okay, let's ignore the greenhouse gases from the recycling, this is what we have in the end. Okay? So when we flared the system before at Trail Road, we produced this much equivalent of greenhouse gases a year. Then we started to produce power. Okay, so that offset our emissions of greenhouse gases. Okay, because over here at the landfill now, this is what we used to produce. Now we offset them. This went down even more because now we diverted that organic component that we used to generate power with, and we send it to Orgo World, where it's composted aerobically to generate a compost. And then there's the value of that compost. Now what's not built into the model is, what is the value of adding that organic material back into our soils and building up our soils that are becoming depleted? Okay, I admit there's lots of numbers in here. But again, on an energy or greenhouse gas perspective, that's what brings it down to here. And then if you go to the bioreactor landfills, it comes down even more because you're capturing more of the landfill gas and converting it into power. Okay? So diverting the organics when we have to collect the landfill gas anyway doesn't make a whole lot of sense from a greenhouse gas emissions point of view. Energy consumption is the same kind of thing. You can see here that recycling, okay, that aluminum can versus all the energy in terms of exploring to find the aluminum, mine the aluminum, transport it, etc. It makes sense to recycle as much as possible. Okay. But again, if I take that remanufacturing out and we go to energy, okay, this is where we were with the trail road when we flared. Then we now produce power at the site, so we decrease the energy use. But now with the green bin, we've diverted those organics again. And we increase the amount of energy that we're using in the system. There's a lot of numbers in this model. It's a very detailed model. But the whole purpose of that modeling is to say that we need to take a step back and look at the bigger picture. Another example is if you look at our number 5 plastics. Okay? We need to recycle things that make economic sense and that make sense from a life cycle perspective in terms of what are the energy costs to collect that material and put it back into plastic. Let me look at, for example, a number 5 recyclable. Okay? If there's not a market there and we're not going to use it effectively and put it back in and save on the petroleum hydrocarbons, we might want to leave that in the waste stream so that when it goes into a Plasco facility or an Enerchem facility, it's turned into energy, because it's going to turn it into energy, okay, and save on the petroleum hydrocarbons anyway. Okay, so you have to look at the big picture and understand where the costs are, where the emissions are, where everything puts together. And I think that's what we have to do, is we have to step back and look at this from a bigger picture. So these are kind of my final thoughts, but we'll get lots of discussion, I'm sure you'll like. Reduce, reuse, and recycle. We have to continue to do that. If you want to put the Waste Management, Waste Services Inc., VFIs out of business, okay, produce less waste. Right? Reuse, reduce, and recycle. Use your power as a purchaser, okay, for packaging. Okay, when you go in and buy a memory stick for your computer, it comes in a plastic like this. Why? So nobody walks out with memory sticks in their pocket. They go back to consumers distributing. I even remember when I was a kid going into consumers distributing. I don't have 35 years experience yet, but, okay? But packaging, we purchase packaging. We like to buy things that are in a nice package, that are got cardboard and a little bit of shiny glass so we can see what's in the package. Right? How many people buy printers? Right? You buy a printer, okay, and then you got to go buy a cartridge for that printer. Well, the cartridge is $2 cheaper than the entire printer. So what do? Well, I'm going to get the entire printer. Why not? Right? It's only $2. There should be legislation in my mind in Ontario that just doesn't allow that, because even that cartridge that's in your printer that you bought isn't quite full. Right? So there's lots of things that we need to do in terms of use our power as a purchaser. Okay? Talk to your MVP counselor. Legislation. Okay? There are lots of things on the legislative side. If you want to look at things happening in Europe and why, there's a number of reasons why we don't go with landfills, for example, versus incineration or energy from waste. Okay, we do have the luxury of space. But again, these companies are providing different technologies. Okay? They're all valid technologies. They're providing services to you and I. We generate the waste. If we want to pay more money, we can do that. Okay? There's a big issue there in terms of it's a societal issue, not in my backyard. I'm going to use the Carp Road facility. Nobody wants to look at an expansion of the Carp Road facility, and there's a group out there that are against it. So why don't we now move it to the east end? That group will be quiet, right? But there'll be another group at the east end. We don't want an east end. We'll move to the south end. Nobody wants it. Okay? Nobody's going to want a Plasco facility next door either. Right? Because there's going to be lots of garbage trucks still coming to whatever facility you have there. Okay? We as a society need to deal with the waste that we generate. Okay? Go back to reuse, reduce, and recycle as much as possible, but it is a societal issue. Okay? We've got to look at cost versus environmental impact. I gave you the, our ICI waste, our institutional, commercial, and industrial waste. Right now, as citizens of Ottawa, okay, we don't want to have a landfill. Okay, we have technologies that are working towards providing alternatives like Plasco and Enerchem and others. But right now, we're putting it on a truck, sending it to the States, and it's all driven by economics. And the impacts on the environment are not good. Okay? That's just in somebody else's backyard. Okay? We need to think about different solutions. Okay? My last bet, or two things, is no more trash talk. I teach, and I enjoy teaching. And we teach engineers to be, we have an environmental engineering program, and we teach engineers to be protective of the environment. Okay? And when they go to locate a new waste management facility south of Ottawa here, I forget who's involved. You know, pardon me? Taggart. Okay, they're providing a service. Okay, yes, we can choose to use that service or not, but when the press come out and say it's a dump, it's not a dump. Okay, it's our MPP that has put out through government legislation in terms of how we design that. It's got a double composite liner. It's several $million, tens of $millions for a liner that's clay with 2 millimeters of plastic, and then gravel and another clay-like liner and another 2 millimeters of plastic, and then some gravel. When I get lawyers calling me from nodump.ca and say, well, we're concerned about the landfill because it's going to impact the groundwater resources, and I say, well, I teach a course on landfill design. And I can tell you that Ontario's legislation over-designs the base of that landfill to protect those groundwater resources. Click. Nobody doesn't want to talk to me anymore. Okay? It is an education thing too, but that's why I say we don't design dumps now. Okay? Well, these are mistakes. We've dealt with mistakes in the past. We had dumps 30, 40 years ago. Now we design engineered containment facilities, whether it be a Plasco facility, whether it be a landfill. It's just different materials. Okay? Yes, the landfill takes up bigger space, and yes, in the landfill, things like the wood and things like the plastics don't degrade or take long times to degrade. The readily degradable fraction does degrade to produce the landfill gas. There's lots of issues that you can deal with. And the last thing is that this paradigm shift. We have to have a different view of things. Is it a waste? Is it a resource? Are we going to be going back into our landfills and do what some people call waste mining? They don't like to call it that because the Mining Act comes into place, so we call it waste reclamation. But do we go back in? We looked at that here in Ottawa. When we looked at the Trail Road expansion of our landfill, okay, one of those options was to go back into stages 1 and 2 that were filled in the 80s that do not have the liner below, and to take that out, recover the metals, recover as much as we can, put a liner system there, and then put it back in there. Okay? And there are other now sites in Ontario and North America where we are going back in and reusing that space because that landfill space, quite frankly, is valuable. Now, if you've got landfill space, so I think we need a paradigm shift, right, from the reuse, recycle, and reduce. Okay, reduce is a big one too. We all like to get the new materials, and look at the amount of electronics that we go through. You know, we're very quick to buy the next iPod. I don't have an iPad. I want to get one. But we're very next. The next generation comes out. We're consumers. Okay, we're heavy consumers. We like to buy the next, the next iPhone, the next everything. And all those other components, we just throw out. But we need to look at a lot of different things because it is an issue that will cost us many, many millions of dollars in the future. Thank you for your attention.